I'm just waiting for some guys to sign in before we begin. Once a person joins, just add your name into the live comment. Also, if there is anyone who has joined, can you please just tell me if the voice is coming alright? Yeah, so I can see that we have 6 viewers right now. If you just add your name in the comment section so that I can know who all are present here. I mean, is my voice coming? I might actually check that. Okay, so I can see 8 people who joined. Okay, let's equal. Just a second, I'll check for that. Is it alright now? Is it still equal? Okay, so hello guys, I'm Mohammad Azhan. I'm currently pursuing BTech in Electrical Engineering from Jamia Islamia, and currently I'm third year of my course. So before I begin, I was going through all of your responses, and there's something I saw that most of the people know about C++ and there are some who know about Python also. So it would be easier for me to begin the course that most people actually know a programming language beforehand. Is it better now? Mm, Just a second, guys. No, just a second. I'm just setting my audio once again. We can try it now. So as I was saying before, given that most people know about C++, it would be easier to proceed. Just like, please give me a voice check again. Let's move closer. System. Just tell me if the voice is coming alright right now. Is the voice alright right now? Should I proceed further? Yes, okay. So as I was saying earlier, now that most of you guys actually know a bit about C++ and other programming languages, it will be easier for me to proceed with. So first of all, let's know about what exactly is Python. So, well, with Python, the very first question is, what is Python? And why is it one of the most used languages? So the very first thing is that Python is a scripting language, and the another main feature of Python is that it is a dynamically typed language. Python is a dynamically typed language. That means once you start coding in Python, the variables and the features are assigned dynamically. So if I just look into the Python console, the very first feature of Python that is very useful for us is that I don't actually need to specify the type of the variable that I'm using. Like in C++, if you guys have coded, I'm quite sure you must have seen that in C++, for declaring an int, you used to declare like int x is equal to value of integer. Now that is not the case with Python. In Python, if you want to declare a number, you just go with x is equal to and value of number. Let's say that I have decided that x is equal to 5, and then I run this piece of code. So it just assigns the value 5 to my x, and if I say print x, it will just return me 5. Now the same variable x cannot be assigned an integer, like I say x is equal to hello world 1, and then I run print x again, and now x is gonna return hello world. So any confusion still now, guys? So I just go on further. Now this was a basic intro of Python. Before we begin actually with the course, I sent a mail to you guys. It's like you would have checked. So in the mail was like how to install Anaconda. So the very prerequisites of this course are installing Anaconda, because Anaconda comes with most of the pip packages that you need to install for machine learning. Now the very best feature of Anaconda is that it is basically a data mining Python IDE. So it comes with most of the libraries already pre-installed with it. So for those of you who do not have seen the mail, I'll just show you how to install Anaconda. Just visit the official website of Anaconda, which is anaconda.org. From there, just go to download Anaconda, and based on your operating system, just select. We'll be using the Python 3.7 version. For Windows users, you can just go for the Windows. For Mac OS, here's your setup, and for Linux, I guess basically everything remains the same. So just install it using Windows. I'm also giving out the link on the live chat for those of you who do not have installed. I'm gonna wait for 5 minutes. Just install Anaconda so that we can begin. And like if you guys have already installed Anaconda, just let me know. Also, if you guys have not understood anything right up to now, you can just ask me in the comment section. Like, feel free to interact, guys. It's all for you. Should we proceed further? Just let me know in the comment section, please. No, you're replying. I'll just proceed further. If any one of you has any doubt or faces any query, just let me know in the comment section. Okay, so I'll just move on further. As we were discussing earlier, Python does not ask you to declare the variable type of any variable that we're declaring. So I can just go on with x is equal to 5 and then print x where x can be a number, and in another statement I just go on with x is equal to 6.2, which means that x is now a float value, and I run this cell and then I just ask Python to print x, and now x becomes 6.2. So if I would like to just know the type of x in each case, it will be like x is equal to 5. Okay. Just a second. Okay. So let's just restart the kernel once. So I declared x is equal to 5, and now I'm gonna ask for the type of x. So print type x, and right now it's showing that x is an integer. Now again x is equal to hello world and print type x. Now x becomes a string. The same x, variable x that was an integer in the previous section, has now been assigned to the class string. So here we can see that we don't actually need to define the data type of any variable. The data type of the variable is assigned as per the value assigned to the variable. Like if I go with x is equal to 6.2, yeah 6.3, and run the code, and then I again ask for the print type of x. Now I get a float value. So the same variable x takes 3 values and gets 3 different data types based on the value assigned to the variable x. Is it clear till now? So I'm just going to assume that it's clear, and we can proceed further. So these were like the type of variables or the variable data types available in Python. Apart from that, we also have a few more data types, but we won't be using them in machine learning. The most common data type that we will be using is int and float. We won't be dealing with string values either in machine learning, because in machine learning we only deal with numerical values. Like even if there's a textual data in any particular problem, we try to convert that textual data into a numerical value. Like we'll be seeing that in the further classes. For now, let's just keep it till here. So now we will be looking at the data structures in Python. So the very first data structure that we have in Python is a list. Now a list in Python is just like an array that we use in C++. To define a list, all you need to do is list name is equal to, you use square brackets and you enter the contents of the list. So like if I need to declare a list in one dimension, it will be like 1, 2, 3, 4, 5 and 6. And then if I go to print list name, here's our list. So this is a one-dimensional list with 6 elements. Now just like C++, Python starts the numbering of any data structure with 0. So to know the very first element of a list, just list name and index of the variable. So if I say list name 0, I get 1. Similarly, list name 5 would get me the last element of the list, 6. So with indexing we mean that the exact position of an element on a list. So the index starts from 0 and goes on till n-1, where n is the length of the list. Index starts from 0 and goes to n-1, where n is the length of the list. Now let's say that we want to know the first 3 elements of a list. So for that, all we need to do is print x colon 3, and this would give us the first 3 elements of the, it's not x, it's list name, and this will give us the first 3 elements of the list, that is 1, 2, 3. Similarly, if we want the last 4 elements of the list, all we need to do is print list name 4 colon, and we get the last 2 elements. I guess it's all clear up till now. Now we'll see adding numbers to a list. Now there are 2 different ways to add numbers to a list. The first way is using extend, or using append. First we'll see how to use extend. So if I have the same list name, and I want to add a value 7 and 8 to the list, I just write list name dot extend and the list 7 comma 8, and I run the code and then print list name, and we see that list is now extended to 1 2 3 4 5 6 7 8. Now let's assume that we want to add a number 9 to the list again. So list name dot append 9 and list name and now we see that 1 2 3 4 5 6 7 8 9. This was all about one-dimensional lists. Now we'll move forward to two-dimensional lists. So let's assume that we have another list named as list2, which we want to make a two-dimensional list. So the definition of the list will go like first square brackets and then two small square brackets and 1 comma 2 3 comma 4, and this becomes just like a 2 by 2 array as we use in C++. So print list2, and we can see that what we get is a two-dimensional array with 1 and 2 in the first row and 3 and 4 in the second row. I guess everything was clear until now. If any one of you has any problem, just ask them in the comment section. So I'm going to move further. Now, here's the thing. Python uses indentation to recognize code structure. Like the very first basis of Python is that it uses indentation to recognize the structure of a code. For example, if I try to run the following code, tab 5, okay, a equal to 6, tab and a. This one. So if you look at the following piece of code, first I declare a is equal to 6, then I give a blank space and print a, and I get an error, unexpected indent. So the thing with Python is that it is an indentation based programming language. Like in C++, uses curly braces to differentiate between different parts of the code. Like for those of you who have programmed in C++, you might know that if I'm declaring a function, let's say, which prints hello world, so void print message. This is for C++. This is the C++ command that I am typing right now. So first comes the function name, then your curly braces start, and there goes your code like cout hello world, and then to declare that the function is closing, we give another curly braces. Now that is not the case with Python. In Python, the same command would be given as, let's assume that the function name is the same, print message. So for Python, function, just a second, it would like the function name, so print message, and then you need to give a tab space to declare the indentation. Space, and then print hello world, and once you're done, you just need to remove the indent and call in the function print message, and that's it, your work is done. You don't need any opening or closing braces to declare the scope of a function. It's your indentation that declares the scope. So similarly for functions in conditional programming, which we will be seeing now, like a is equal to, in the previous example where I said a is equal to 6, I gave an unexpected space and said print a, the error was unexpected indent. So if I would just remove the indent and run the code again, see a print a, and we get the value 6. So I hope it's all clear till now. The next section that we will be working on is conditional programming. So for those of you who have already gone through C++, you might know what conditional programming already is. So there's no point in repeating all that structure, but still, here's a recap for conditional programming. Specific code snippet based on user defined conditions. So conditional programming is like we have got few snippets of code that we would like to run based on any preset user defined conditions. So for example, the Basic example of conditional programming that we have is if else. Now, most of you would already know how to use the if else programming structure, so here's just a quick recap. In case any one of you does not know, please just let me know in the comment section. I'll go through it again. So I'm going to declare a variable x, not exactly x, let's go with variable something like abc. So I set the value of abc to 7, and then I'm gonna just run a condition if abc is greater than 10, then comes the colon, print larger than 10, else print smaller than 10. So in the given example, the value of abc is currently set as 7, and my code says if the value of abc is greater than 10, then the first part of the code, that is print larger than 10, is going to be run, and then comes the second condition, else print smaller than 10. So I'm going to run this piece of code right now, and we see that the output is smaller than 10. Now I'm going to change the value of abc to 12, and I'll be running this piece of code again, and this time it prints larger than 10. So if else allows me to use two conditions on any given variable or data type. But what if we have more than two conditions? Like suppose I need to make a grading system. If else works when there are only two conditions to be set. But in a grading condition, like for example, if a student secures marks between 90 to 100, he gets a grade A. Between 80 to 89, he gets a grade B. From 70 to 79, he gets the grade C, and for less than 79, he gets a grade D. So here we see that we have four multiple conditions. Like if the student gets between 90 to 100, it's an A grade. Else, if the grade lies between 80 to 89, it's a B. Else, between 70 to 79, it's a C. And if he has marks or the grade less than 79, it's a D. So here else if cannot work, because as we have seen earlier, if else uses only two conditions. So just like in C++ we had if else if followed by else. Similarly in Python we have if, elif, elif, and in the end else. So we'll be using the same grading condition that we decided on the previous page. So let's just declare a variable grade which is equal to, let's say 87 for now. So if grade is smaller than 100 and grade is greater than 90, print A. If grade smaller than 90 and grade is greater than 80, print B. If grade is smaller than 80 and grade is greater than 70, print C. Else print B. So I just run it. Just a second. So, yeah, so this messed up the conditions a little. So for 87 we get the B grade, right? Now let's just increase the marks to 95. And it becomes an A grade. So I hope till now it's all clear. I'll just wait for 2 minutes if you guys want to try this out, and then we want to proceed further. Okay, so now we are gonna move ahead. The next topic is loops. Now, what exactly is a loop? So, in a loop, a specific part of the code is run until a preset condition is met. That is, a specific part of the code is iterated again and again until a preset condition is met. So based on this definition, any loop must have, I guess, three main criterions. The first would be initiation, which is starting of the loop. The next would be our condition, where the preset condition is being checked. And the last would be updation, because obviously if the condition was not updating variables, because obviously if the condition was not met in the previous iteration, the value of any variables must be updated before the next iteration is run, so that in the next check it may or may not satisfy the condition. So a very good example of showing you a very basic loop is, like, let's assume I want to iterate over the values of integers from 1 to 10. So I want to start at 1 and I want to stop at 10. So for the given condition, the initiation would be x is equal to 1, where x is our integer. Next, the condition would be x is equal to 10, and in the end updating the variables. So we start with x and we want to go up to 10. So obviously we are going to go step by step. It's not like we just start with x and in the next step want to go to 10. Our goal was to go to 10, like 1, 2, 3, 4. So the updating the variables would mean x is equal to the previous value of x plus 1. So in the first run x was 1. In the second run the new value of x would be the previous value of x, that is 1, plus 1, 2. In the next run it would again be checked if x is equal to 10, but then 2 is not equal to 10. So the value would be updated. The new value of x would be the previous value, that is 2 plus 1, 3, and now the new value of x would be set to 3. So in the next one again x would be compared with 10, and again 3 is not equal to 10. So the loop will be run again until we get x is equal to 10, where the condition would be checked, the condition would hold true, and loop breaks. So here is a basic example of a for loop. Like in Python we have two main loops, for and while. So first we'll go with for loop and then we wanna look at while loop. So here's for loop. Let's assume a variable y that we would iterate over for y in range 1 to 10. Now we use the function in range for initiates the loop. Y is the variable which we want the loop to run on. In range means the specific conditions for the loop, where the very first value is initiation, the next value is the condition, and leaving the next value empty would mean that the steps would be taken as 1. So for y in range 1 to 10, let's just print y and look at what we get. We start with 1 and we go to 9 because this 10 here is not the like greater than or equal to 10. The condition is checked like the value of function should be smaller than 10. So if you want to go till 10, all you have to do is set 11. So that 10 is included in the range and we get 1 to 10. Now imagine if I wanted the steps to be plus 2 and not 1. Like I wanted 1, 3, 5, 7 and 9. So all I would need to do is add another integer, the step integer, which is 2. So now once I have added 2 and I run the code again, our output becomes 1, 3, 5, 7 and 9. So I'm just gonna add it to the comments for the bracket. The very first is the initiation value. The next is the stop value, which is not included in the range. So if I want to go up till 10, I have to write 11. And the next is the step or updation value. I hope for loop is clear to you guys. So I just move on to the next while loop. I'm gonna give you 2 minutes to code. In case any of you faces any problem, just write it down in the comment section. So I'm gonna move ahead. So the very next topic is while loop. So for a while loop, the declaration goes like, first we initiate a variable. So let's just say that z is equal to 0. The next step is setting the loop while, and then comes the condition. So let's assume that now we want to go from z is equal to 0 to z is equal to 10. So z is smaller than 11, and again a colon and indent. So here's an important point. For any piece of command or any function that you want to run, you put up a colon and then give an indentation for the specific code, for the specific range. Now let's imagine, let's see with y. So I'm gonna go with y, z is smaller than 11. I'm gonna print z, and now I'm gonna write z is equal to z plus 1 first here, and we wanna check for the output, and we see that it's from 0 to 10. Just a second. So now I'm gonna run the same command again. The only difference is this time I'll be removing the indentation from the second piece of code. That is, from the updation part, I'm gonna remove the comment. I'm gonna remove the indent and run this piece of code again. And this time what we have upon us is an infinite loop, as you guys can see. Just want to stop it right here. So if we scroll down even further, we give a keyboard interrupt. But the thing is, we actually remove the indent. So the next part, z is equal to z plus 1, was not included inside the loop. So the value of z was never updated and it remained 0, and the value was printed 0 throughout the loop. And since 0 is always smaller than 11, the loop continues infinitely. So let me remove this. So this was your while loop. I'm gonna write the conditions again. Declare a variable while condition, give an indent, followed by code snippet, and then at last updating the variable. So this is how the basic while loop works in Python. So I guess it's all clear until now. Next, we will be working on functions. This was all about loops. Next is functions. Now again, the major difference between C++ and Python in scope of functions is that C++ functions needed to declare a return type. Now imagine this. Like it's a very basic problem that I ask the user for a number to check whether the number, or wait, just wait a second please. Yeah, so let's just assume that I create a function division in C++, which has a return type integer. Return type of integer. Now the function is declared as int divide, takes an integer int x and then return x divided by 3. So now the main problem is that if I input the integer x, which is divisible by 3, obviously I get an integer in return. But what if I enter 5? Now 5 divided by 3 should return a float value, as you all know. But because the return type of the integer of the function is set as int, we would get an integer value in return. Like the decimal part of the quotient would be removed. So the same is not the case with Python, as Python functions don't have a specified return type. So when I say Python functions don't have a specific return type, they obviously do return a value which you want them to, but the compiler would not want you to declare what kind of value you are returning from the function. So the simple definition of a function in Python would go like def function name and parameters followed by colon and obviously the indentation and code. So let's take that. I want to create a function which finds out whether any given number is even or odd. So like we'll be working on a very basic problem here, whether any given function is even or odd. So for that, first I need to declare my function, that is def even or odd, takes an integer x, and here comes the definition of the function. If x modulus 2 is equal to 0, return even, else return odd. So here is a very basic definition of the function. I'm going to explain it to you. The very first is the keyword def, which defines that the following sequence of code is a function. The next piece of information is our function name, even or odd. And inside the parenthesis we have the function parameter or the input x. Then we have the condition if x is x modulus 2. Yeah, so modulus returns the remainder when x is divided by 2. So if I say x modulus 2, it means the remainder when x is divided by 2. Similarly, x modulus 3 would mean the remainder when x is divided by 3. So obviously for checking whether a number is even or odd, we would find the modulus with respect to 2, where if the remainder is 0, if the remainder of the number divided by 2 is 0, it is obviously an even number. If the remainder is not equal to 0, it is an odd number. That was quite simple. So we have the function, and now I'm just going to check it using result is equal to even or odd for 5. uh, on X. Just a second. Oh, we run these, and then I'm gonna run this, and now I'm gonna just check for the value of result, and we have result as odd. Now I'm just gonna run this piece of code again. Now I'll take an even input, that is 12. Run it again, and now our result becomes even. So here's how you declare a function in Python. Functions. So this was the basic definition of a function in Python. I hope it's clear until now. Like if you guys have any queries related to whatever I am speaking right here, you can just ask them in the comment section. So should we proceed ahead? Like people just give me a heads up. Should we proceed ahead? Just comment yes, please. Given that you guys have no doubts, like just please do a piece of code for me. Open up ide.codingblocks.com and just change the language to Python. And I need you people to write a function that prints whether an integer is prime or not. Just use this ide.codingblocks, write a function that prints whether an integer is prime or not, and then save it, and then just share the link. Like for example, if I save it, so the link obviously changes. Just copy this link and paste it on the comment section here, like this. Just try it out for once. It does not matter that the code has to be absolutely correct. Just try doing for once. write a function that returns whether an input integer is prime or not. Just try it out, guys, for once. I'm gonna give you guys 5 minutes. So anyone, like क्या सही होना पूरा करेक्ट एकदम जरूरी नहीं है, कुछ तो ट्राई करो, कुछ तो किया ही होगा ऑब्वियसली, एटलीस्ट उतना ही पोस्ट कर दो. किसी ने कुछ भी नहीं लिखा, मतलब सीरियसली भाई प्लीज फंक्शन डिक्लेयर तो किया होगा, कुछ तो सोचा होगा, उतना ही पोस्ट कर दो यार. ऑब्वियसली फर्स्ट रिव्यू में किसी का सही नहीं होता, लेकिन एटलीस्ट कुछ तो शो करोगे कि समझ में आ रहा है, नहीं समझ में आ रहा, मेरे को कैसे पता चलेगा इस साइड से. तुमने बोल दिया हाँ सब क्लियर है. Please just post whatever you have put it up until now. किसी ने भी ट्राई नहीं करा सीरियसली, कुछ तो सोचा होगा यार, कुछ तो ट्राई किया होगा. Okay, Koini, let's move ahead. So this was all the basics of Python that you needed to know for the coming machine learning program. Like this is more than enough. We won't be using Java. So now the next topic for our today's discussion is machine learning. So what exactly is machine learning? The very first question that arises when anyone hears the word machine learning is what exactly is machine learning? Like करते क्या है इसमें? Anyone who has any idea? Let's move ahead. So machine learning is the use of computer programming which learns by example. Now what exactly is an example? Machine learning uses the information provided by the user and learns it for the future coming tasks given to it. Like any particular algorithm learns learns certain rules from the given data set or from the given problem and it applies those rules in the coming tasks provided to it. So if I were to summarize it in a word, machine learning is the use of computer program to learn by example provided by the user. Like the user gives a given set of examples for the program to learn. The program develops a set of rules from the given examples. These set of rules form an algorithm. So when we talk about machine learning, it's like you give the computer any set examples, a given set of examples, and you ask him or you ask it to learn from the given set so that when you give him a new task, it should perform that task based on the rules that it has deduced from the above given examples. So if I would put it plainly, it's like I have a data set which contains different examples to any function where the function is obviously unknown, but I know the input value of the function and the exact output value. And now I've asked my program to look at these inputs and their respective outputs and then devise a set of rules on the basis of these given examples so that when I give him a new input value, it would give me a predicted value. A much more simple way to put it is like I have data set. Like if you would have checked your mail, the data set contained various income parameters of families, and the target variable or the prediction variable was the family annual income. So there, the examples that I gave the program was the set of the data set, obviously, where the examples were meant to teach the program using these the different income parameters. Like it would tell the algorithm that these set of income parameters produce this set of results for any given set of income parameters. This label out there is the family annual income. So that is plainly putting what machine learning actually is. So the next step is how do we teach the computer? Now there arise two different steps. One is supervised machine learning, and then comes unsupervised machine learning. The main difference between these is that in supervised machine learning, you provide the labels to the program to learn from. That is, the labels are provided by the user. For a given example, if I must say, it's like for any given day, the temperature, the humidity, and the wind speed gives out a particular probability of the factor whether it would rain or not. So if I provide a program with the wind speed, the features are the wind speed and temperature and humidity, and the output feature would be probability of raining. So if we provide both the input features and the output feature to the program to learn from, we call it as supervised machine learning, because here we actually supervise the learning procedure. We give the program the input features, we give it the output of what must be the value, and then we ask it to learn these set of rules. In an unsupervised machine learning model, the output feature is not provided by the user. The user provides only the input features and not the output features. So it's up to the computer to decide and analyze this unstructured data and find the useful information in it. Whereas in supervised machine learning, it obviously has the labels and only has to decide a set of rules to produce those labels. So in our course, we shall be discussing only on supervised machine learning models. We shall only be this discussing about supervised machine learning series. Just a second, please. क्या हुआ? नहीं नहीं sorry for the interruption. So let's move ahead. So when we look at supervised machine learning models, we actually have two different ways to proceed with them too. Or for any model as such. The first is regression. The second is classification. Now, what exactly is regression and what is classification? So first we want to discuss regression. So regression is all about discussing continuous values when the labels used when the labels are continuous values. For example, if I have to tell you it like that, put it like this: the previous example of prediction of annual income of a family, that was a case where the labels were continuous values. Like like the income can lie between anything from 1,000 to 10,000 to lakhs. It is a continuous set of values. You can't like put it into different classes, or you just can't put it into two different classes or three different classes. Obviously the income would be a real number which can lie between 0 to lakhs or crores depending upon the input features. So when we need to deal with an output data which has continuous values, we use regression, whereas classification is used when the output labels need to be sorted into classes. For example, let's take any probability case. So there are two different cases for any probability case: whether the thing will happen or the event won't happen. So when I put it like that, there are two different classes. The first class is class 0, where the event does not occur, or the class 1, where the event occurs. So in a classification model, the output can either be 0 or 1. Similarly, this was the example of a binary classification. Similarly, we have multi-class classification also. So in classification, we have binary classification and multi-class classification. So when I talk about binary classification, it's like comparing the probability of two different cases. So an example of binary classification is obviously whether it will rain or not. So let us assume that the case 0 is it does not rain, and the case 1 is it rains. So if the output is 0, then obviously it will not rain, and if the output is 1, it rains. But now the real question is, how does the computer know whether it will rain or not? So the back end side of the problem is that the computer exactly does not know that whether it will exactly rain or it will not exactly rain. What it knows is the probability of whether it will rain or whether it will not rain. And then it compares both of the probabilities. For example, if I say that the probability of raining today is 65% and the probability that it does not rain is 35%, and I have set the threshold on 50%, that if any class has a probability greater than 50%, I'm going to assume that that event occurs. So obviously my model is going to say that it is going to rain because the prediction that it will be raining was 65%. But that is the case with the binary classification where there occur only 2 events. What if I have a multi-class event? For example, if I take up the stocks market, for example, now there can be 3 different cases whether the prices of the commodity will increase, whether it will remain same, that is no change, or whether it will decrease. Now we have 3 different outputs for the problem. So obviously we are going to get 3 different probabilities. The probability whether the market will rise, the probability whether the market will not rise and stay the same, and the probability whether the market will fall. This is the case of a multi-class classification. So in multi-class classification, we may have n different classes. So what should be the way to proceed in a multi-class classification problem? So what actually happens is that we calculate the probability using 1 versus all. That is, the probability is calculated using 1 versus all. Now what exactly is 1 versus all? So let's take an example for this, the previous stock market example. In the 1 versus all approach, what we do is we form 2 different classes again. One that is a target event, and the second is the non-target event. So if I am calculating whether the market will rise or not rise, so the probability that the market will rise will contain the probability that the market rises, and the probability that the market will not rise will contain both events. The market remains the same and the market falls. And using this, the probability is calculated for the first event, that is the market rises, versus the remaining 2 events that was supposed to be the all events. Similarly, we calculate the probability whether the market will remain same versus whether the market rises or the market falls. And using this, we get 3 different probabilities. We get n different probabilities, and with these n different probabilities, the class with the highest probability is set as the label. Now this was the case of a multi-class classification where we had n different cases, and earlier we discussed about binary classification, which contain only 2 different classes. Now the actual problem is that how do we know that any given classifier is actually a good classifier or it is not? Before we move into that, we want to discuss regression, and then we want to check for scorings. So now we further proceed to regression models. Now, as I said earlier, regression models are used when the labels are continuous values. So, for example, if I have a data set that has obviously the weather parameters of the area and it predicts weather, or rather, it predicts the average temperature of the day. So, obviously, we cannot exactly divide the temperature into classes. Like, we cannot exactly say that the temperature will either be 36 degrees centigrade or 37 degrees centigrade. It can be any value between 36 to 37. So obviously we can't use a classification problem because it's not a classification problem to begin with. We have the labels as a continuous series of data. So we need the output to be a continuous series of data also. So how do we proceed in such cases? We use regression models. Now what most regression models do is they try to find the similarity between the input features and the output feature. Like the very first regression models that we have is a linear regression model. So what a linear regression model tries to do is it tries to find a linear characteristic between the input feature and the output feature. For example, if I compare the temperature to the chances that it will, or rather, if I compare the temperature during the day to the mean rainfall height of the area, obviously the higher the temperature, the less would be the rainfall height. So similarly, we can look for different cases where the model tries to find a correlation between any two features and predict the coefficients to form an equation for the model. So the main regression models that we will be discussing here are linear regression models, which include simple linear regression, lasso regression models, ridge regression models, and multiple linear regression models. So I'm going to give you just a basic insight of each of the models that I have written here. Let's start with simple linear regression model. Let's just assume that I have a function of y in terms of x, where x is the only variable present in the function. So in case of linear regression model, the function is just the same. So it's like in simple linear regression models, we have target variable x, a target variable y, and an input variable x. Now what a model tries to do is that it tries to fit the variable x and y into the model to look for any linear correlation between the target and the input variable. Now if you would just look into your datasets that I have provided, the dataset that I have provided you in the mail, you can look at different columns and their value, and at the end of the lecture I will obviously show you some graphs which will tell us whether any two given parameters have a linear relation or not. So a simple linear regression model tries to do is that it tries to find the best fitting line in our data set between x and y, and in doing so it obviously may or may not exclude many data points because we assume the data to be linear. Now the data does not exactly need to be linear. The data can be a little shifted upward or downward. It may have a slightly curve shaped points, but what we assume is that the input features and the output feature have a linear relationship between them, and we try to use this linear relationship to predict the labels. Now, that being said, it is not obviously possible for the model to predict each and every point on the given data set. That's where lasso and ridge regression comes in. Now, it may be the case that due to some disturbance or some exceptions, the data set may have a slightly higher point for an input. Like if I'm going to give you an example, so the image that we see right here, this shows a linear relationship between the input feature X and target feature Y. But this may not always be the case. For example, if I look into some other example, or let's just first understand linear regression through this graph. So what we have done is, using these data points given in our data set, we try to find a line, this red line that we see. We try to find a line that best fits our data, that tries to obtain the maximum features of the given input data set, that tries to copy the data set at the maximum instances it could. But obviously that is not always possible, because we can see that most of these points do not exactly lie on this line. They lie either above the line or below the line. Now, while in this example the deviation of the points from the line is not so great, it may not always be the case. For example, if we look at outliers, so looking at this model, the data point which is right on the top does not fit the linear model quite well. Like the deviation of the points below is quite less as compared to the point right above shown here. I hope you guys are understanding, right? Like this deviated value is known as an outlier of the current data set, because what actually happens is that the true value is quite large than the predicted value. So there is quite a large deviation which would give us significant errors. So we use lasso and ridge regression for calculating these penalties. Like in our further models, we'll see how lasso and ridge regression create a term penalty in the equation of a simple linear regression model to account for these outliers. The last model is a multiple linear regression model. Now what actually a multiple linear regression model does is that instead of taking a single variable x, it tries to take different variables x, y, z and so on as the input feature. And using these multiple input features, the model tries to find a label for the target variable y. Now, apart from these regression models, we have various other regression models that include KNN and decision tree, random forest, name phase, etc. So we will be discussing about each of these models in detail in the coming lectures. And as for today, let's just keep it till here. I hope everything was clear. I'll still try my best. In case you still have any doubts, feel free to ask. So let's just keep the session till here, guys. In the next session, we will discuss about regression models and using these regression models to predict the outcome of a variable. And before that, before that, in tomorrow's lecture, we would be focusing on exploratory data analysis, which is EDTA, and plotting the data, and various other data exploratory methods and data pre-processing techniques. And if we still have any time left, we would first start with regression models and then the classification models. That's all for today. So I just want to end this session right here. I hope you guys had a good time. So goodbye.